Hello and welcome to the Why Plant Recovery Audits Improve Performance webinar. I am your organizer, Michelle Beacom, Managing Editor of CIM Magazine. My co-organizer is Ryan Bergen, Editor-in-Chief of CIM Magazine. Our panelists presenting today are Mike McCubbing of SRC's Geoanalytical Laboratories Diamond Services and Jane Denoxy of SRC's Mining and Minerals Division. We thank all our attendees for joining us today. Just a little housekeeping before we get started. To ensure that you have optimal audio, if you are joining on your computer, make sure that you have selected the computer audio button. If you are joining on your phone, make sure that you have selected the phone button. If you have any questions during the presentation, please type them into the question box in the GoToWebinar control panel. The questions will be held until the end during the question and answer period. And note that we will have 2 poll questions during the presentation, so pay attention. Now we will switch over to our presenters to give you the webinar, Jane Denoxy and Mike McCubbing. Sorry. Okay, here we go.
Good day, my name is Jane Denoxy and we will be speaking about processing plant audits.
I'm Mike McCubbing with the Saskatchewan Research Council. I'm a geoscientist. I've been with the SRC for probably about 18 years now. I supervise the Geoanalytical Lab Diamond Services. We do microdiamond analysis. We've got a mini bulk sample plant for bulk sample processing of kimberlite, and then we do a lot of diamond characterization work. So the Geoanalytical Lab has been in business for close to 40 years, and we've been operating at the Diamond Lab in the north end of Saskatoon for just over 12, but have been doing diamond work for decades. A little more background about SRC. So the Saskatchewan Research Council is one of Canada's leading providers of research and technology development and technology commercialization. The mining and minerals team provides services that meet industry needs across the mining cycle for a wide range of commodities, including diamonds, uranium, potash, lithium, base metals, precious metals, and rare earth elements. So the goal here is to provide technological solutions across the full mining spectrum, all the way from geoscience and initial exploration and greenfield studies, all the way through to mine site remediation and reclamation. The Geoanalytical Diamond Services Department is a world-class facility. Again, over 40 years of service in the potash and uranium industries in Saskatchewan, being strategic commodities. But over the past several decades as well, we've developed an international reputation for diamond work. So here you can see the caustic fusion facility, where we've got 80 kilns for sodium hydroxide fusion, which gives us a capacity of about 70 metric tons annually for microdiamond analysis. And so we've got a worldwide operation and a reputation that is unmatched as far as I'm concerned for the services that we provide to the diamond industry. Our mini bulk sample plant is a 5-ton an hour plant with full automation circuit, lots of feedback controls, and so that gives us a lot of opportunities to try different things in different cut points and different settings, and making sure that we're pushing the limits of what the equipment allows us to do, and find out different ways of processing and threshold limits. On the bottom right of the screen, that's the final recovery area, and just in the front of that is an interesting machine. It's a benchtop X-ray, and that's some of the new services that we've been offering in recent years with our applied diamond services, which we're providing diamond characterization work, which includes diamond typing by FTIR, diamond luminescence studies using the single particle X-ray sorter, breakage studies, densimetrics, and a whole host of other analyses to characterize the diamonds and get a better understanding of those specific deposits. So here's just a quick slide on some of the abbreviations. If you aren't familiar with them, this is how we'll be using them in this webinar.
Just a quick outline of what we want to cover in this webinar is we're going to give you, well, we've had the brief introduction, the equipment, how you would do an audit with equipment inspections. Then you would look at the efficiencies, and that will be determined by a partition curve. Then we would look at traces and how we would actually generate a partition curve. Then the next step would be to look at your ore, so collect samples from around your process equipment. Then we would look at the recovery efficiencies, which is a number of calculations. So there is going to be some formulas in the presentation. And then we would actually put all the data together to give us an overall plant performance efficiency. And then we would look at some conclusions to draw from our analysis.
So just the basic introduction to kimberlite geology. So as you can see, there's the three main kind of deposit types as outlined by Scott Smith et al. In 2013. On the far left, you've got the green Fort Alacorin type pyroclastic kimberlite, in the where it's more of a concentric funnel shape with a very shallow basin. This is going to be wide variety of grain sizes. You've got pyroclastics, you've got infill. You're going to have a different mineralogy and good preservation potential for the kimberlite because you have the full column intact. In the center, we're looking at more of a kind of a typical type steep-sided kimberlite, more of a funnel shape, where you've got the horizontal resedimented layers with the more of the green pyroclastic kimberlite infilling at the bottom. And what this is going to change is as you develop this mine, you're going to have different lenses and different zones where the mineralogy of that specific kimberlite is in a transition. And when you get those slight mineralogical adjustments, that can change your cut points, that can change your density, it can change your yields, and really have an effect on your overall performance of your process plant, of your recovery rates, and then you can mitigate that by doing some preliminary analysis on those grain sizes and mineralogy to do a little more predictive geology, I guess, per se, when you get down into the different units and the different zones. On the far right, here's more of a textbook Kimberley style pyroclastic kimberlite, where you've got some transitional, sorry about that, some transitional zones towards the blue, more coherent kimberlite at the base of the eruption, and in that zone you're going to have different hardnesses of rock, which again go into how that rock breaks up in your comminution circuit, the grain shapes, the grain sizes, which can also have an effect on your cyclone performance and the hydrodynamics that are occurring inside that cyclone, which is going to be doing a majority of the work if you're looking at a 1% yield on your throughput. So again, more basics on the kimberlite mineralogy. pretty broad suite of indicator minerals that are associated with these kimberlites. You can see them here. They have a variety of densities, more on the heavier side. But the one thing to focus in on here is kimberlite, being a volcanic rock, it's going to have a lighter density. And that can range from 2.2, and we've seen kimberlite densities with a bulk rock density of up to 3.2. When you get dense kimberlite, you can try to push up your cut point on your process plant, but you don't want to risk, obviously, floating off any of the material that you want in your concentrate. Which means that most of your concentrate is going to be comprised of your pyrope garnets, your eclogitic garnets, some chrome diopside, chromite, picker ilmenite are going to be the denser minerals in there. Olivine is going to have a dramatic effect on your yields because of that range and specific gravity. You can have a high cut point and still start removing some of that olivine, but it all depends on your EP values and where you feel comfortable at your D50 to ensure that you're getting an accurate cut and a smooth transition to be able to push your density up and get an effective yield.
So just moving on to the process plant design. Usually when they've done your exploration of a deposit, then you would start designing your plant, and the parameters that you would consider is your commodity, the grade, the value. Then you would start looking at what are the differences between your host ore as well as the commodity residing in the host ore. And that would dictate what technologies and what processes you would want to utilize to maximize on those differences. Then other things to consider is your country rock characteristics. Is there a lot of overburden? So would you go open pit or underground? Your grain sizes, how is your commodity held within the host rock? Is it large or small? Like Mike's been saying, the competency of the rock, is it hard or softer? So what kind of combination are you going to be using throughout your plant design? What are the clay contents? And also, what are the effects of the environment? If you live in Canada, everything's got to be under shelter, whereas if you're in a warmer climate, then you can actually just have it in the open area. So to start off with a plant audit, the first thing that you would do is an inspection of your equipment. So the things to look at is your wear. What are the dials saying? Have they been properly calibrated? Have there been blockages? And do you have any monitors measuring the level of what is contained in the various processes? So you need to take a document of all of those attributes of the equipment, and if possible, take photographs. Photographs are very, very valuable, especially when you want to go back to what did this look like, or when you want to explain a circumstance to another person. Then we would start to look at the equipment, just general. The bulk sampling equipment or bulk sample sorters would go up front, with your particle sorters later on in the flow sheet. So you want to really get rid of as much bulk as possible and remove as much waste as possible. Then the next thing to do is a tracer test. So I've got here two pieces of equipment, both the density cyclone as well as an X-ray machine, which is a particle sorter. Although we are concentrating on diamond recovery, these attributes can be superimposed on any other processing plant. And along with what we're going to discuss now is tracers. You can get tracers for a whole load of different equipment processes. So for magnetics, you would have magnetic tracers. And here on our X-ray machine, we've got luminescent, so we've got the luminescent tracers. But I just want to go over now how you would carry out a tracer test. The reason why I like tracers is because they are repeatable. And you can actually store them or get more manufactured, and they don't change. When you find with an ore body, when you try and look at just doing your audits from assays, you find that your ore body has changed and you're not monitoring those changes. So with the tracers, like I said, density tracers, great for cyclones. I know a lot of different mining operations use the density tracers. Magnetic tracers for magnetic separation, they come in a whole lot of different magnetic susceptibilities. We use luminescent tracers to monitor our X-ray machines. Hydrophobic tracers can be used for grease as well as they have been used in flotation. Color tracers, shape tracers, and then atomic density tracers are used for the new XRT technology, which is also going into a number of operations. So density tracer test, it is as accurate as the number of tracers that you put in. So if you put in 50 tracers per cut point, you're looking at a 2% accuracy for each data point. What I've shown here is the results of a tracer test. Now, sometimes you can lose a tracer, and in such a situation, you would then make your percentage recovery out of, say, 49 or 48, depending on if you put in 50 tracers. So that's how you would just modify your calculations on your efficiencies of recovery at that specific gravity or magnetic susceptibility or luminescence intensity. What we've done here is actually just plot your various points on a partition curve of what the tracer tests were given to you, or what the results produced, and then you would put a partition curve through those data points. So that is, a partition curve is a curve that would actually best match those data points. And the important points then in the partition curve is your D50, which in this graph is at 2.77 SG, the D25 at 2.74 SG, and your D75 at 2.8 SG. And from those, from the D25 and the D75, you get your EP value, which is the sharpness or how vertical your curve is at your cut point. Okay, I did say to you that there was going to be a number of calculations and formulas in this presentation. This is the formula for the partition curve, and it's pretty straightforward in that the SG is your density, are the points that you got from your tracer test from at each density. So SG is for your at each density point on your x-axis on your partition curve. And then the SG you could change for magnetic susceptibility, or you could change it for luminescence intensity, or if you're actually using your partition curve to evaluate a screen, a sizing screen, then that SG will be particle size. And there is your EP value, which is a function of your D75 value and your D25 value. And I've used D here because it's using density. So you could have that as an M for your magnetic cut point at 75% passing, or your magnetic cut point at 25% passing. So that's how you would generate your EP values for each of your partition curves. And now we have a poll question.
The poll is in progress. I'm waiting for everybody to vote. I'm at 80%, and it seems to be holding. Oh. Okay, it's at 82%, but I'm going to close the poll now. And there are the results. You can see 32% time, 29% for budget, 17% for personnel, 12% for other priorities, and 10% for value. Thank you very much, and we will go back to the presentation now.
Thank you. Okay, so moving back to partition curves, what I've done here is just generate a partition curve for a density cyclone. I use a density cyclone because it is in quite prominent use at a number of different mining operations. And you can see here that not only is your partition curve a function of your density, it's also a function of your particle size. So the coarser the particles, the lower the density cut point, and the finer the particle size, the higher the density cut point. So you're separating both on density and on size in this case. And thus, if your plant mineralogy changes, either it becomes finer or more coarse, so you can see that your density cut point in your cyclone will also change, which is why your audit is a function of both your equipment as well as your mineralogy. Here I've got a partition curve for a screen. You can do a similar kind of test where you have your traces at different sizes, or usually people just do this on the assay, and you can look at how well your screen separated at different sizes. Although this aperture on this screen is 3 millimeters, the actual 50% cut point was at 2.65 millimeters. Now we've got some more equations. The recovery efficiency, just generally overall, your recovery efficiency is a mass of what you've been the commodity of what you've been able to recover all over the mass of the commodity in the ore body. But this equation doesn't tell you much unless you break it up into what is due to the equipment performance and what is due to the mineralogy of the ore. So you can see I've got the green equations is the mineralogy for at D50, and the, say, turquoise color is your equipment performance and your mineralogy at D75. I'm going to just concentrate on the D50, but usually I do work with the D75 because the D50 says you've got a 50-50 chance of it either going to the floats or the sinks or the concentrate or the tails. So let's just look at the D50s. We see that your equipment performance is determined by how much of your commodity was recovered over how much of your commodity is greater than your D50. So how much of your commodity was recovered over what the equipment can do. And then your second green equation is your geology of the ore, which says how much of the ore body is over the D50 over how much of your commodity is in the ore body. So that tells you how well your equipment is matched up to the host rock. And of course, when you take the product of the two green equations, you see that the denominator of the top equation is the numerator of the bottom equation, and you come straight back up to your first equation. And you can do the same thing at the D75. Then your last equation, which is an important equation as well, is how much waste that technology has been able to remove at that point in your flow sheet. The objective is to try and remove as much waste as possible, as soon as possible in your flow sheet. Now we're going to go on to a little bit more of the importance of the geology.
So one way of starting an audit on a plant is to be taking a sample for densimetrics, and this can be taken just with a few kilograms of material from your feed, and then from your float and your sink screen on your various size cyclones that you're using in that particular plant, and then we can screen them out into the proportional size fractions that are the relevant cutoffs for the investigation that you're completing. And what we'll do is do a densimetric analysis on grain size and density. And so we use LST, which is a heavy liquid lithium heteropolytungstate, and you can control the density of that by superheating it. And then we've got some other techniques that we can actually get the density up to about 3.5 Sg. So you can get quite a broad range of densities to then put the data set together, correlating the densities on your different profiles from 2.8, 2.9, 3, 3.1, 3.2, all the way up to 3.53, and different size fractions. And that'll give you the mineral abundances in those particular size classes, in those particular density ranges. And so that'll also be helpful in the mass balance in determining your expected yields at certain cut points based on your partition curves. And then you can also use it to compare different technologies. And this is kind of the precursor to a full 3-curve analysis that you can perform on those particular cyclones to quantify if there's misplaced materials or if you've got potential for lockup, and the density of that kimberlite and how that can change if you had a diamond embedded particle still in that piece of kimberlite that can affect the density and increase the potential of floating off diamonds being entrained in that later density kimberlite. So here we have a graph showing the results of the densimetric analysis. So you can see your bias here is in your 3.2 Sg range, and then what that would indicate is a high olivine content. And so if you are running a density on your cyclone of less than 3 with a D50, you would expect to recover a lot of that olivine in your yields, and that would likely spike your yield to a fairly high amount. If the plant performance allows and you have the confidence in the cyclone, you can maybe push that density up to 3.1 or 3.15, and to see if you can start floating off some of that olivine and reduce your yields and have that benefit downstream into your recovery and into your sort house. But that goes to show that it's not just olivine, but you can have other mineral species that can also fall into that 3.2 to 3.1 range, where you can have an effective cut point to improve those yields and at the end of the day improve the economics of the process plant.
So I hope from these couple of examples you can see that your recovery efficiency is a function of both your equipment as well as your mineralogy. That olivine, that would report to either the floats or the sinks, depending on where your cut point is. And as you are mining through your whole deposit, so you can see that your mineralogy changes, and thus your whole plant performance would change. Like I said, waste removal was the last equation on the last sheet, very important. And the objectives are to actually reduce as much as you can as soon as possible in the flow sheet. And when you're doing that, you get reductions in your plant design, you get reductions in your equipment requirements downstream, you get a smaller footprint of your plant. So you have a number of benefits that would improve the economics of your process. So I've got yellow rings around the different processes in your plant that you can audit. So the next screen I'm going to be showing you is where we've actually done audits on all of those different processes and now putting it all together so you've got a complete overall process plant audit. So again, taking an example of a diamond processing plant where we're recovering diamonds that are larger than 0.85 millimeters. What you can see here is I've broken up into all the different process stages. So the first thing is your liberation. You should be able to liberate all the diamonds. It's just breaking the rock open so that you can liberate them. However, how the equipment performs due to the rock competency is a function of the rock competency, and you can see at the D50 you will get a slightly higher value than you would at the D90, D75. And here, this is a function of the smaller particles just being an opportunity for them to be locked up within that host rock. Screening, I've given you some audit results of the screening. DMS performs well, but you can see that this is also a function of your D50 cut point, whereabouts you are taking these measurements from. So this is a function of your parameters that you've set. What you can see here, okay, I'm just going to go down. Magnetics will be the next process after DMS. Then you would have X-rays sorting on your DMS, on your magnetic concentrate. SPS is a single particle sorter, and it's using X-rays, and that will be sorting your X-ray concentrate. And then you would notice that your X-rays, especially when it's the smaller diamonds, does not recover. When you look at your mineralogy, you'll find that your diamonds do not actually luminesce well. The small diamonds do not luminesce well. And you're looking at around about a 78% performance. Now, to actually mitigate that poor performance, you would use a scavenger technology. And what we use as a scavenger technology is grease. Now, when you come to the overall performance of your plant, you can see that we're just going to go over the D50. So after the liberation, you are at 98.5%. It's a product of both your equipment efficiency and your mineralogy. Then when you get to the screening, you'll see that's a product of your mineralogy and your equipment for screening multiplied by the concentrate on the previous process. And so it goes on. DMS is down to 97% because it is the product of the mineralogy and the equipment times by the concentrate from the preceding process. So when you get down to the X-rays, you are at 73.8% recovery efficiency. So what the scavenger technology does is it treats the tails. And now we've got a 20% recovery on our tailings, and that needs to be added to what you recovered on your X-rays or final X-rays, your SPS, to give you the overall recovery at that stage of 94%, 94.38%. Then, of course, you would go to your hand sorting, which is now their efficiency on your concentrate, and the hand sorting 2, which would be looking at the tailings of the hand sorting 1 to make sure they haven't missed anything, and then those two would be added together to give you an overall plant efficiency of 94.38%. If you are looking at your D75% recovery, though, that would drop to 91.5%, 91.9%. So that's how you will put all of your recovery efficiencies together. It's a product of both your mineralogy and your equipment, and then looking at the preceding processes. And then from that, you can see which technology is weak and where you would need a scavenger technology or a second pass. As we've got in our hand sorters, you can see that as a second pass. Now you can compare this to another audit, but this audit is for a mine that only recovers from 3mm diamonds upwards. And then you can see here in this audit that the X-rays are, the mineralogy is at 90% recovery, and also the liberation is higher because it's easier to liberate the larger stones from your host rock. And here, the D50, then overall plant recovery is higher at 97.16%. So there you can start comparing your audits for whether you're changing your bottom cut point, and that would also change how your overall plant efficiency is performing. So these are very important to look at what your cut point is, how you are running the mine, and the geology and your wear and the environmental conditions. Have another poll question?
Okay, it looks like everybody has voted. I'm going to close the poll. Oh, we still have people voting. Okay. Oh. Okay, I'm closing the poll. And here are the results. We have 70% of people who voted saying yes, they will attend the next Diamond Series webinar. It's on understanding and mitigating diamond breakage. There'll be more about that later when we're finished this presentation. And 30% who say maybe, with 0 who say no. Thank you very much, and we will go back to the presentation now.
So to conclude, what those last 2 screens were showing you about the results for a complete plant audit is that audits do enable you to evaluate each technology and to decide whether your cut points or your performance, your operating parameters are correct and to be optimized for your geology in the host rock or the geology in your deposit. The audits also quantify how well the technology is processing the ore. And then regular audits enable you to quantify the effect of seasonal changes, geological changes, and the effects of equipment wear. So you can monitor all of those attributes of your plant with an audit. Then the technological weaknesses of your flow sheet can also be identified. So where you would want to have a scavenger technology incorporated, or you would want to be looking for upgrades on that technology that's happening all the time and say, yes, I want to evaluate now my process or my equipment with the latest technology, and you've got numbers to compare it with, which is very important. And overall, your plant audit provides a number in which you can quantify how your plant is doing and where opportunities are for improvement, and that can all relate to economic valuation of your plant. And like I always say, to measure is to know, and that was first of all stated by Lord Kelvin. Thank you.
So thanks for joining us today. If you have any questions, feel free to email either myself or Jane at the contacts that are shown on the screen right now. Judging by the poll results, that's encouraging that you'll be joining us for the next webinar. And we're targeting May 7th for that one, where we're going to be discussing diamond breakage and understanding and mitigating diamond breakage.
Great. Well, thank you very much, Jane and Mike. Now, if for anyone out there who has questions, you can just type them into the question box. I would hope you find on the right-hand side of your screen. I do have a couple questions for you. First of all, how does someone carry out an audit if they don't have tracers or simulants?
Well, I'll start off with that question. If you don't have tracers or simulants, you can use parts of your commodity. So you can actually reserve a handful of your commodity and use that specifically for spiking your processes on each of your equipment processes. What I would recommend is whatever that commodity is that you've selected to do the spiking, to actually keep it aside, because otherwise your commodity or your host rock changes, and if there are changes in your commodity, then you can't pick those up. So actually keep a sample of your commodity to the side so that you can use that for tracer tests and for spiking throughout the life of the mine.
Yeah, another option is to do a densimetric analysis where you get the actual mineral abundance and mode of mineralogy through the different density profiles. So you'll actually get a percentage weight based on each density profile on the mineralogy itself at that given point where you're sampling off of the cyclone itself.
Okay, thanks. So I have another question for you. I believe it also relates to tracers. Someone's asking, I believe you maybe mentioned the name of a liquid that changes density depending on temperature.
Yeah, so the lithium heteropolytungstate, LST. So that's the heavy liquid that we use, and so we'll be able to control that using a heated jacket, heated flask, and you'll be able to, with heat, you can increase the density of that fluid to gain those higher density cutoffs upwards of 3.5. We use some additives with that as well, just to increase the density. But the LST is a more suitable option than the previous heavy liquids that you use, which is TBE, which is carcinogenic. So it's a much safer option where you can run some of these density profiles. We also do heavy liquids using methylene iodide, but again, with the TBE, you can get the higher density profiles with that.
Great, thank you. And what if someone can only do an audit on half the equipment or the process in the plant?
In such a case, then you would need to make an assumption on how different equipment is performing. To be honest, I didn't do an audit on the crushers on the liberation stage, but I made some assumptions, and knowing what the lockup has been in the past from, looking at assays, I've been able to establish what the performance is. So you can make educated guesses on equipment that is difficult to audit.
Okay, great. And what happens if the equipment settings change?
So when the equipment settings change, then, you would need to do another tracer test, either a tracer test and an assay, or if you don't have the tracers, do an assay of every time that you change the equipment. So you do need to, as soon as you change the parameters on the equipment, you do need to have where exactly your D50 or your D75 cut point is and draw up the new partition curves whenever you change parameters.
Yeah, and I think the idea of doing audits and these spot checks is to be a little more proactive than reactive. So you're actually knowing beforehand what the expected mineralogical changes or particle size changes that you might be expecting if you're going into a different unit or a different zone. Then you can kind of preempt and make those changes up front rather than having to say, okay, we've got a problem with a plant and there's too many fines coming in, or a different profile, your screening efficiencies aren't quite what you expected based on the different unit, that you're not having to shut down and make those changes after the fact and risk any of the adverse effects that you might have gone through processing material that you could have been better prepared for.
Okay.
Yeah. Knowing your mining plan and knowing what geology is going to be sent to you, and being, like Mike says, proactive.
Great. So someone asks, I found that using curve fitting software for tracer tests is not always as good as drawing by hand. It can have a big influence in your D25, D50, and D75 readings. Do you have comments on that?
I personally prefer the formula because then you know it's consistent. So if you are going to be changing parameters and moving your cut point up and down, the formula always fits it, like mathematically, as opposed to sketching or drawing where you're kind of like guessing where you're going to be drawing the line between 2 points. So I do personally prefer the calculation and the mathematical fitting of the curve.
Yeah, so we kind of fall somewhere in between where we're not necessarily using the software that's available. We're not doing it by hand, but we've developed algorithms internally to provide our partition curves to us.
Okay.
I use solver, yeah.
And then another asks, how do you determine statistically representative sample sizes for auditing of plant tails, especially in lower grade ore?
Okay, just repeat the question. How do I determine? How do we determine statistically sized sample size?
How do you determine statistically representative sample sizes for auditing of plant tails, especially in lower grade ore?
Statistics, to me, is a tough one. In that, okay, I can give you a quote from a statistician who has worked practically his whole life on kimberlite, and he said to actually get a representative sample of kimberlite, you would need the amount of kimberlite that's larger than the kimberlite fascie itself, because it's so varied and there's so many different attributes in the ore body. So, you just got to work out to what is economically viable as well as statistically and with equations, what will give you a good result. So there isn't I feel, a good answer for that one.
Yeah, well, another way of going about it is to not necessarily focus on diamond recovery itself, but looking at, again, modal mineralogy and the kimberlite indicators, which are going to be more abundant than the diamonds in that deposit anyways.
Yes.
So if you can do a density profile and you can take that resulting puck and get some heavies out of that, run a QUIM scan analysis, and it'll give you modal mineralogy, and then you can run your densities on indicator minerals and use those as a proxy for the diamonds, because they'll have associated densities with those.
Okay. And then someone else asks, do you use geometric sizes for particle size EP curves?
Geometrical sizes?
Geometrical sizes, I'm not sure.
It's not size dependent. I mean, you can use whatever sizes you want. Yeah, I'm not restricted by.
Yeah, with the tracers, they come in different sizes, all the way from, I think, down to 1 millimeter, all the way up to 8 to 10 to 16 millimeters.
25.
25 in some cases. So for the size of the tracers that you're using for your calibration test, they've got to be proportional to the size of the cyclone that you're running and the size of the material that you're trying to recover. Yes. I hope that answers the question.
Do you mass balance for screen data to make a self-consistent set of data?
Yes, very important. Yeah.
Okay.
Yeah. Everything gets weighed.
Could you comment regarding the samplers used for your surveys? Do you use your own, or do you use ones available at site of the survey?
Usually, if it's more convenient to have people taking the samples at site, but we can definitely provide the type of instruction that would be needed to gather that information. And so that would just be a matter of some initial correspondence to understand the flow sheet, to understand the collection points or the potential collection points, how many that you're trying to audit, if there's anything that, so it's all kind of bespoke to what you're actually trying to achieve. And then you can come up with a sampling program and procedure, and we can definitely assist with coming up with those.
Yeah, but when I have gone to site, I have taken my own equipment. Because sometimes the sites don't have all the equipment needed to, like do the right sampling or the right measurements. Yeah. But I mean, the equipment's pretty straightforward, so easy enough.
Just, I believe, one final question here. Involved in the plant audit?
You broke up there for a little bit.
Yeah, we missed you.
Please?
Can different groups within a company be involved in the plant audit?
Definitely.
Yeah, that would probably be encouraged, just to make sure that there's buy-in through geology and processing and the actual miners themselves. I think that just is a way to kind of unify it too, to make sure that there's a common understanding. Because if you're doing predictive assays and you're looking at results based on predictive changes, then yeah, obviously you want to have the geology group involved, and because they'll have a good database and data set on the logs and on the core to find out where those units and zones are.
And then added to that, usually the people running the comminution section of the plant is different to the people running the recovery section of the plant. So you would really want the people in recovery to do the audit of their equipment, and then the people in comminution to do the performance of their equipment, and then you would collect that data and put it all together. It doesn't, they can all be different people and generating the information, the geologist, the metallurgist, putting it all together to get you your final plant performance.
Okay, sorry, we do have another question. It was, after you have completed an audit, how do you quickly determine the changes needed and costs required to improve efficiency? I don't know if that's a segue into the next one.
Well, we're looking at the data. So if you're doing it with your partition curves, I've showed you, like in the middle of the presentation, how you would break it up into whether it's an equipment that's losing your commodity or whether it's the mineralogy. If it's the mineralogy, then you would need to change your processing parameters for an improvement. And whether it's the equipment, then you would either want to look at, okay, is there an upgrade or changing your cut point, changing your processing parameters to actually improve your recovery. And then the other aspect is, if it is performing weakly, then you might want to look at a scavenger technology. So they are all opportunities. Whereabouts is the problem occurring? Is it on the mineralogy? Is it on the equipment? And then what you can do about it.
Okay, super. Well, thank you, Jane and Mike. I think I'll throw to you, Michelle. Welcome back.
Well, thank you, everyone. If anybody has any further questions, I'll ask Jane and Mike to put the slide back one to the contact information for you two. Is that possible? Maybe. And anyway, at the end of this webinar, we thank you very much for joining us. We will, a survey will pop up onto your screen, and we hope that you will take the survey. A video recording of this webinar will be emailed to you later this afternoon as well, and the video will also be on the CIM Magazine website and the SRC website. Thanks again for joining us today, and we hope to see you at the second in the Diamond series, Finding the Next Big Ones Intact, Understanding and Mitigating Diamond Breakage. It's on May 7th at noon Eastern Daylight Savings Time, and registration is open now for it, and a link to register will be in the follow-up email you received this afternoon. And we hope to see you then. Thanks very much, and that's the end of our first webinar in the Diamond series. Thank you. Bye.
Thanks.
Thank you.
Bye.